All right, this concept is going to be focusing on something called percent yields, another calculation to add into Unit 7. All right, in our last concept, we completed mass-to-mass calculations. We were given the mass of a reaction or product and asked to find the mass of another reactant or product. So what we did was we saw that in this example, 8 grams of methane, we could expect to produce 18 grams of water using our mass-to-mass calculation. If you remember, we took the grams of our given, converted it to moles, used the moles from the given equation, and then converted moles to grams of our target compound or element. So while this is great to know that yes, if we have 8 grams of methane, we should expect to make 18 grams of water, the reality is that in a lab, we rarely produce as much as what we predicted by theory. So the percent yield compares the amount predicted with the amount that we actually produce in our lab. This is the formula, measure value over theoretical value times 100%. This is not in your reference table. This is something that you're going to have to memorize. The measure value is what we would get in our lab results. The theoretical value would what we'd be able to calculate, with paper and pencil. All right, so here's our first problem. You can go ahead and take a look at the problem. You're going to see, as I'm trying to get this set up here, that we're given 2.5 grams of zinc. This is reacting in an excess of hydrochloric acid to produce 0.060 grams of hydrogen gas. What is the percent yield? So our first thing that we always have to do is calculate the theoretical yield. This is our mass-to-mass calculation. So how much hydrogen gas should have been produced, theoretically, with 2.5 grams of zinc? So as we've done before, we're going to start with our given value. So that's 2.5 grams of zinc, and remember to label it with reactant or product. Again, we're going to be doing a mass-to-mass calculation, so you should know that we're going to be setting up 3 different conversion factors here. Remember, we're going from here grams to moles, so we're going to have grams of zinc, which is going to be equal to 1 mole of zinc. Okay, this is going to be your GFM of zinc, which is 65.41 grams of zinc. We're then going to use the coefficients from our equation, and again, this is just a mass-to-mass calculation. We've already done this. We want to go from moles of zinc, remembering that whatever is our unit in our numerator has to be our unit in our denominator. So moles of zinc, and we're going to moles of hydrogen. Okay, looking up, we can see that we have a 1 for zinc. And then if we look at hydrogen, we also have a 1. So it's 1-to-1 ratio. And then our last one is going to go from 1 mole of hydrogen to grams of hydrogen using the GFM. All right, if we go ahead and solve that, we get that our theoretical value should be 0.077 grams of H2. And again, this is our theoretical value. Okay, so now we have that, we can take that theoretical value and compare it with our measure value, which is the 0.06 grams of hydrogen gas. So determining our percent yield, we have our formula. We know that our measured value is going to be the 0.060 grams, and our theoretical value, which we just calculated, is 0.077 grams times 100%, and when we calculate that, we get a 78% yield. Oops, sorry, putting that I in the wrong place. All right, so if you feel comfortable with this, go ahead and complete this next problem. We're going to see that it's very similar. Just point out the fact that we're looking for the percent yield of water. So we have 2 grams of methane, that's going to be a reaction that we're using, and it ends up producing 3.85 grams of water. So remember to go ahead and calculate the theoretical yield of water, and then comparing that using the percent yield calculation. So when you pause it, try it out, and then you can come back and compare. I'm going to go ahead and start with my given value. So I have my 2 grams of methane, and methane is CH4. Those are one of those common names that you guys need to memorize. Our first conversion factor, just like before, is going to go from grams of methane to a mole of methane. Those 2 values need to be equal to each other, so we're going to use the GFM of methane. Adding that up, we get 16 grams. We're then going to compare the mole ratio, so moles of methane to moles of water. Okay, we can see up here that we have 1 mole of methane for every 2 moles of water. We can then go ahead then and convert from moles of water to grams of water using the GFM, which is 18 grams of water. Alright, going ahead and multiplying across the top, dividing by the bottom, you're going to see that our theoretical yield is 4.50 grams of H2O. Alright, so if we had 2 grams of methane that was reacting that we used in the lab, we would expect to yield 4.5 grams of water. However, we've only produced 3.85 grams. So we're going to go ahead, calculate our percent yield, again using the same exact formula. Our measure value was 3.85 grams. Our theoretical value that we just calculated was 4.50 grams times 100%. We then find, if we calculate that we get an 85.6% yield. Okay, so obviously if you compare the two problems, we have better percent yield in our lab in our second scenario, so we can also use that to compare, again, lab results or different trials that we may complete. Alright, that's all you need to know for this. We'll be practicing this tomorrow in class.